Hi folks, welcome to this video on impulse, okay? So this is one of the topics on biomechanics. What is impulse? Well, it can be categorised as a change in momentum, and if you remember, what is momentum? Momentum equals mass times velocity. So big player running at you at high speeds is very difficult to stop compared to a smaller player running at you at lower speeds, because the bigger player running at high velocities has the greater momentum. Impulse is a change in momentum. More specifically, impulse equals force times time. Now, something I've got to be aware of is, if I was to write it like that in an exam, I wouldn't get the marks because I forgot to do one crucial thing, and that is the units. Force is measured in newtons, time is measured in seconds, and impulse is measured in newtons per second. Okay? Now the key thing about impulse is, generally in sport we want high impulses, but the thing we don't have a lot of is time. Okay? We're asked to do things very, very quickly. What is impulse equal to? The amount of force you can produce multiplied by the time that you produce it. Okay? But what we don't have a lot of is time in sport. We're always asked to do things quicker, less time on the ball, less time in contact with the ground. Okay? So what we've got to do is maximise our force, but sometimes we can maximise the time that we are in contact with objects. Prime example of that is something like a golf swing. What we always told to do on a golf swing, we've got to follow through. We don't just finish with the club there and the ball shoots off. By following through with the club, by swinging the club all the way around, the club head stays in contact with the ball for a fraction of a second longer. But that's enough to increase the time that you apply the force, and therefore increase the impulse and get maximum distance on your drive. Okay, so we can increase impulses by increasing the forces and increasing the time that we're in contact with objects. What I would say about impulse is we're basically talking about two things. We can use impulse either to speed things up or slow things down. That's well worth remembering. For example, this golfer here is hitting the ball with a good, so he's producing high levels of force. He's got to follow through to increase the amount of time the club head is in contact with the ball, and that will increase the impulse, and that will speed the ball up, and it will travel a greater distance. However, think about a cricketer, or when you play rounders, what you're always told to do when you catch a cricket ball or a rounders ball, you're told to catch it and bring it in to your body, as opposed to just sticking your hands out and letting the ball hit it. First of all, that'd hurt, but secondly, if I can catch the ball and then bring the ball into my chest, I'm increasing the amount of time the ball is applying force to my hand, because I'm cushioning it and bringing it in. That's going to increase the impulse but slow the ball down into my hands, and it's going to make it easier to catch. So we can use impulse to speed things up or slow things down. So what else do we need to know? We need to know about a graphical representation of impulse, what we can call force time graphs or impulse graphs, because what is impulse? It's force times time. Okay, so what we can do is, the best example to this is, think of a sprinter. Okay, now there is no better sprinter than that man, Usain Bolt. Okay, now what we might be asked to do is draw a graph, an impulse graph or a force time graph, explaining what is going on at the sprint start. Now what does one look like? Well, it looks like this. We've got a y-axis and an x-axis. Now on the y-axis, y to the sky, the one that goes vertically upwards, we have force in newtons, and on the x-axis we have time in seconds. Okay, now as you might expect, that point there is 0. Okay, so anything above this line, this x-axis, is positive, anything below it is negative. Okay, now Usain Bolt, during a sprint start, he's going to push back on the blocks, okay, and he's going to try and accelerate outwards. Now what would a graph look like for you? It would look like this. Now what have I just done then? Okay, that is our negative impulse. This is positive impulse. Going back to the previous slide, impulse can either speed you up or slow you down. Negative impulses slow you down, positive impulses speed you up. What is the negative impulse? He generates a small amount of negative impulse every time his heel strikes on the ground. Okay? So when his heel, if you look at this, imagine, I know I can't wind on, but imagine this leg is going to stretch out, the knee's going to extend, and his heel is going to hit the track there. That's going to act as like a little mini braking force. Think about it, push your heel into the ground. What does it do? It brakes you. It decelerates you. So every time his heel hits the ground, he's going to produce a very small negative impulse during a sprint start. But what is he then going to do? He's going to push off with his toes. Then he's going to rock from his heel onto his toes, and the toes are going to drive him forwards. And that's going to create a positive impulse. And we can sometimes call that toe off. So we've got heel strike and toe off. What is he going to do? What is this an impulse graph showing? It's showing a period of rapid acceleration. Why? Because the positive impulse is greater than the negative impulse. Okay? So this is going to typically be 0 to 30 metres when the athlete's trying to accelerate. What happens when he's at, let's say, 30 to 70 metres in the race? So he's upright running now. He's out of his drive phase, his acceleration phase. He's now into his full flow. What is a force, time or an impulse graph going to look like now? Okay, well again, got time in seconds. And again, I've got force in newtons. And there's 0 again, the worst 0 in the world, but never mind. Right. What is he going to achieve during this stage of the run, 30 to 70 metres, is constant velocity. Now what that means is, that means his negative impulse must now be the same as his positive impulse. So there's negative impulse again. That's when his heel hits the track, heel strike, and when he pushes off with his toes, he's going to produce his positive impulse. He's applying force over a period of time. You know, look at his feet. It's not the best picture in the world, but look at his feet in this picture. That's toe off. Oh, he's just gone from toe off. He's pushed off on the balls of his feet, driving him forwards. That's positive impulse. But what must have happened first? That heel there must have hit the ground first. You've got to hit the ground with your heel first. And that would have produced a small braking force, but it's matched by the positive force. So the result is no acceleration, but constant velocity. That's what he achieves during the second part of the race. What I would say is it's worth mentioning, you must always draw negative impulse first. You must always draw negative impulse first, because the heel always hits the ground first when you're running. I know it sounds quite flippant, but that's what you must do. Okay? So there are two force, time or impulse graphs for a sprint start and the midpoint in a race. So the last question is, what happens at the end? Now, what do all sprinters do towards the end of a race? They all slow down, even the great man himself. Now, it might be that he's slowing down because he's just taken his foot off the gas. He knows it's already in the bag. But equally, link biomechanics to anatomy and physiology. He's going to be running out of PC. He's going to be running out of phosphocreatine. So he's depleting a fuel source, which means he's not going to be generating as much force when he pushes off. So what is his force time graph going to look like for the back end of a race? I should just quickly write in there. So we're looking at 70 to 100 metres. Okay, so let's write, oops, got that one a bit wrong. See how easy it is to make the mistakes. Let's get time in there in seconds, and force in newtons. Because he's now decelerating, he's slowing down, the negative impulse is going to be much greater than the positive impulse. Okay, so there's negative impulse again, and there's positive impulse. Why? He's leaning, look at him in that picture, he's leaning back, the heel strike, he's not trying anymore, so the toe off is going to be much less, this positive impulse, the heel strike is going to be much greater, and that's going to cause him to decelerate, that's going to slow him down. But even if he wasn't, all these guys are still working as hard as they can, but they're all producing bigger negative impulses and smaller positive, because they're getting tired, they're not generating as much power at toe off, as much force in time with the ground, so that's something to be aware of. So that in essence is how you draw a force time graph, and that's what we're looking at in terms of impulse, force that you're applying over a certain period of time. Golden rules are, don't forget your units for force, newtons, time, seconds, impulse, newtons per second. Don't forget we can use impulse to slow things down or speed them up. Negative impulses slow us down, positive impulses speed them up. And that's how we use to draw the graphs and describe the motion of a performer. Okay, good luck with it, folks.